Welcome to my lecture on automotive science. Today we are here to discuss vehicle propulsion. Now, the heart behind any vehicle is the internal combustion engine. This is what gets the car moving and actually is very inefficient. After all the thermodynamic combustion that occurs, only about 15% of the thermodynamic energy is delivered to the wheels. A lot of that energy is spent cooling and lubricating the system and lost to friction. So the internal combustion engine takes gasoline and air and stored potential energy, and then through a series of combustive reactions creates kinetic energy, which is directly delivered to the wheels. What does this mean for the vehicle? The hot buzzwords that auto enthusiasts are always talking about are torque and horsepower. And they're related but very different. The old saying is torque gets you going and horsepower keeps you going. And that is true to some extent. Before we look at the diagrams of torque and horsepower and how they are related and how they affect your vehicle, it's important to understand some physics. If you recall the basic physics of motion, Newton's second law, force equals mass times acceleration, right? One of the most basic laws. It takes a certain force to put anything in motion. Work is force times distance. So that's the amount of force or amount of energy that is used to move anything. And then power is work divided by time. That's the rate at which work is done. Now, what does this mean for an engine? Now, an engine, which creates rotational power or angular power, has its own set of equations. So, equal to force is torque. Torque equals force times radius. So think of a rotating wheel or gear. It's the force multiplied by that radius. All right, that's why a bigger gear or a bigger swing arm will create a greater torque. The power equivalent of this, which we measure in horsepowers, is torque times the angular velocity, in the engine's case a crankshaft, that's measured in RPM. And specific to horsepower it's divided by 5 to 5 2. So you can see actually when the crankshaft is rotating at 52 RPMs, these cancel out. Horsepower actually equals torque. Okay? So what's the range on torque? The internal combustion engine has a very narrow, remember, it's inefficient, has a very narrow range of angular velocity. Minimum idle speed is 1,000 RPMs. Any less than that, the engine will stall. Maximum in most vehicles is about 7,000. Now compare that to a modern day electric engine, which goes all the way from 0 to 22,000 RPMs. It's perfectly efficient, does not need a gearbox to transmit energy. All right, but the internal combustion engine has a very, very narrow range. And remember, a lot of the energy is lost due to lubrication, cooling, and friction. So at low RPMs, torque starts here. Peak torque of an engine occurs at about 4,000, and then it starts to diminish. And at 4,000 RPMs, that is when the piston heads, the engine, are most volumetrically efficient. Right? That is when you can maximize gasoline and oxygen into the piston. So when the crankshaft is rotating at 4,000 RPMs, that is when a car has its peak torque. Now horsepower, remember, is torque times the velocity. Horsepower will continue to increase. Even after the torque, after it loses its peak torque, as you increase RPMs or angular velocity, horsepower will still continue to increase. So remember, they cross at 5,252, 52. All right, horsepower equals torque. All right, red is torque, black is horsepower. The power band of the engine, which is really when the engine is most efficient, starts at about peak torque at 4,000, goes all the way up to its maximum RPM at 7,000. So that's considered the power band of the engine. So at low velocity, low RPM, you need a lot of torque. As the car begins to accelerate, you need less torque, and horsepower continues to increase. So they are directly related. Later we'll discuss how this torque is transmitted through a series of gear ratios and a gearbox with having bigger gears. At slow speeds, you need a lot of torque. You need to maximize torque, but you can at slow speeds crank your engine up to 4,000 RPM, so you start with a very large gear ratio to get your car going. Okay, more on that next discussion. Thank you for watching my video on automotive science.